Hello and welcome to a new episode of Library of the Week. Today we will be talking about Geopandas, a library for geospatial data analysis with Python. This is part of a Medium series I do about Python libraries. I try to do them weekly. You can find in the description of the video the link to the Medium article I wrote about Geopandas. Geopandas is the essential library for geospatial data analysis with Python, just like Pandas is the essential library when you want to work with non-geographical, we could say, data in Python. GeoPandas can transform pandas data frames into geo data frames by adding to each line geographical information. So this is usually latitude and longitude that can then be displayed in a map for geographical data visualization, or that can be used to perform geographical data analysis. There are special algorithms that we can run to find spatial relationships between points or lines or polygons. We're going to see that in a second. It also allows to work with raster data. So this is image data, image like the one generated by satellites, for example. And it does this by integrating with other geospatial libraries in the Python ecosystem. Geopandas has great documentation. It is extremely complete and I highly recommend that you check it out. It is a project that has evolved a lot in the last years and there is just so many things you can do with Geopandas. Geopandas is a community-led project. There is a lot of contributions. It has a very big ecosystem and integrates with a lot of other geographic libraries that we will probably be looking with more detail in other sections of Library of the Week. So this means that, for example, GeoPandas can handle pandas data frame, can use Shapery to give geometry to the pandas data frames. You can easily create matplotlib maps or even volume maps, so these are interactive maps. You can do a lot of things with GeoPandas. Geopandas is a NUM-focused sponsored project, just like Pandas or Matplotlib that we saw in previous editions of Library of the Week. And there are over 2,600 questions on Stack Overflow. Let's now see some basic statistics. As of September the 20th of 2023, we are in version 0.14. There has been over 5 million downloads in the last 30 days on PIPY, over 3 million Conda downloads. The first release is from August the 1st of 2013, and the latest release is from September the 15th. There are 5 dependencies, and on GitHub, the project has almost 4,000 stars, 872 forks, 106 watchers, and 204 contributors. The library has a source rank of 22 in libraries.io. Let's now see some examples on how to use GeoPandas. The first thing we need is some data to work with. I'm going to use a natural earth dataset. So you can come to the Natural Earth website. The link is in the description of the video and also in the Medium article. And so you come to this page and click on download all 110 cultural themes and you download it. In my case, it's already done. So I come back to my Jupyter notebook. So here is the zip file with my data. You don't need to unzip it. GeoPandas can open this zip file for you. You can also choose, as I did, to unzip it and see what is inside. This zip file contains several layers of geographical information, and once it is zipped, it is all merged together. The first thing we need to do is to import GeoPandas. I import it as GPD, just like usually we import pandas as PD, and I create a world object with gpd.read file, the name of my file, so the zip file I just downloaded, it's in the same directory, and I do a sample just like you do it with pandas. So I'm going to see the 5 random rows in my data frame. So here we have it: Dominican Republic, Guyana, France, Croatia, Fiji. All these are countries with some data information about them. And you can see geometry. So this is the area that the country covers in the map. GeoPandas is partially based on pandas, and we can use a lot of pandas methods to work with our geo data frame, just like if it was a data frame. We can, for example, see all the columns that are contained in this geo data frame. So for that I use the dot columns. We can also use the pandas describe method. In this case I just want to describe a subset of the POP-S, so the population for each country, and the GDP for each country expressed in $1,000,000. So for example, we see our minimum value is 140 for the population. So in this data set I think we have some territories that are not technically countries, such as Antarctica, for example. Maybe this is why we have such a small number here. And the maximum population is 1.4 billion. We can also use the dot plot method, and this is going to create a basic matplotlib map. Let's now check some more complex examples. First of all, I want to create a subset of my geodata frame. Geopandas is good at this, just like pandas is. You can do data frame transformations. In my case, I want to keep a subset is only the Asian countries. I only keep the subset, the lines with the continent matches the word Asia. So obviously we're gonna keep the Asian countries. And with this part here, what I'm doing is I'm keeping only these columns. So I want the name, so my country is identified, population estimate, GDP, and the geometry, so I can draw maps on them. I use the dot copy method, so this is so I am not working the original data frame, I create a copy of it. I sort the values by name, and I do a reset index, so I don't keep the original one, right? I want new fresh index for my new fresh data frame. Another thing I can do is create calculated columns. So in this case, my data frame, I'm going to add it a GDP per capita column. And I do this by dividing the GDP by the population estimate. The GDP, I also multiply it by 1 million because it is expressed in $1,000,000. And once I have divided by population, most people in the world don't have a net worth of expressed in millions, right? And then I use the dot head method to see the first rows of my data frame. Now that we have a proper data frame to work with, we can do some more advanced visualizations with it. So not just a map with the boundaries. So we use Matplotlib, we don't need to import it. With it, we're going to do a choropleth map. So for that, we use the data frame or the geodata frame that we just created and use the plot method. With the column parameter, what we're going to do is break by GDP per capita to assign a differential color to each country in our Asian countries data frame, and this will be based on the GDP per capita. I also add legend equal true to have a legend, and I use a color map. So CMAP stands for color map. Viridis is one of them, but you have many different color maps available. Some are better for continuous variables, some are better for discrete ones. Viridis is a good scale for continuous variables, and GDP per capita is continuous. It's not categoric. I do the set axis off. So for example, here we have this axis that show the coordinates. It can be useful sometimes, but it's not very beautiful usually. And I set the title to have a better looking map. And here we have it, each country. So this is China, Japan, South and North Korea, Mongolia. Well, you have all the Asian countries with their GDP per capita expressed here. So now we have our visualization. This is great, but let's say that we want to do some actual spatial analysis, because this is probably the greatest thing that we can do with geographical information. Maps is the cool part, but spatial analysis is what really has the most value. So in this example, what I want to do is for each country in my Asian countries data frame, I want to know what are the odds for each country to be neighboring a country that is richer in GDP per capita than itself. And to do this, well, we create a empty set called country odds, and then we're going to iterate over the pandas data frame rows. So this is something usually to avoid, to iterate over the rows, but I didn't find a better way to do it. For each row, we get the name and the value for GDP per capita. And then for each row, we see what the neighbor countries are within our data frame. So what we do is use the geometry.touches, and it allows us to get a subset with all the neighbors. Then we get an even smaller subset of the neighbors, which is the richer neighbors. In this case, the richer neighbors have a GDP per capita that is bigger than the GDP per capita of the current country. And we finish with calculation of the odds, which is the length of the richer neighbors. So this is the number of lines of the subset data frame that has the neighboring countries that are richer, divided by the subset which has all the neighbors, whether they're richer or not. And we only do this if we have neighbors, right? Because if not, this is basically a statement to avoid division by 0. And I end with appending or assigning to the dictionary country odds. I said set before, but it's a dictionary, sorry. So I add the odds we just calculated to the dictionary where the key is the country name. And at the end, I use this dictionary to create a new column in our data frame, and I use the head method to display it. So let's see what we have. And we could even plot these odds in a map to have a visualization. In this case, I use the different color map. So you see you have a lot to choose from. So check the documentation for color maps, and you'll see that you can use pretty neat scales to show your data. And the last thing we can do, and this is not really part of the complex example, but it goes at the end of your analysis, is to save your new data frames. So the Asia synthetic data frame that we just created, we can use the to-file Geopandas method, and we have to specify a driver. In this case, I'm going to save it in GeoJSON format, which is great when you have files that are not extremely huge, and this is definitely the case, right? So that's it for today. I hope you liked this video about Geopandas. Like it if you liked it, subscribe to the channel if you like these Python libraries videos, and don't hesitate to leave a comment with Python libraries that you would like me to talk about or any other subject that you would like me to cover. And until next time.